Hey everyone. Yesterday we explored how to create sine and cosine graphs. We graphed by hand and kind of analyzed those graphs afterwards. Today we're focusing on just kind of formalizing what those key features were that we talked about. So on our left hand on our screen here, we have our sine graph. It's graphed with both radians on the bottom and degrees. Notice how those are lining up in the key spots. And then we also have this table on the right. And this table on your note sheet is blank. And what we want to do is pause your screen, fill this out, and then we can talk about it real fast. But notice this first box here, these minimum and maximum values. Our max value is 1. If you look at your graph, you'll see that at a height of 1, that is how high my sine wave will go. And similarly, our minimum value of -1 follows that same bound on the opposite side, where the minimum, the lowest point that we'll hit, is -1 there. And then another key thing to point out is we start at 0 degrees. We start at a height of 0 here. Our value at 0 degrees or 0 radians is 0. The sine graph starts at 0, works its way up to 1, back down, crosses 0 again, and then hits our minimum point. This sine graph is going to repeat every 360 degrees. It might seem like it repeats every 180 degrees because it does reach back down to 0 at this point here. But notice how it only completed that positive portion of the wave. It also needs to complete that negative portion of the wave to get the full cycle. So it repeats every 360 degrees or every 2 pi radians. And that distance can be kind of shown right here. And finally, the last important thing to point out about a sine wave is we're going to cross every 180 degrees starting at 0. So at 0 degrees, 0 radians, we're at a height of 0. At 180 degrees or pi radians, we're at a height of 0. And again, at 2 pi or 360, we're at a height of 0. If we worked backwards into negative rotation, the same thing holds, right? Every 180 degrees, we're crossing that line. Let's move on to the cosine graph. A lot of similarities here, but it is slightly different. So go ahead, copy down that table. You can do it as I'm talking, or if you want to pause the screen and come back, that's fine. Again, that max value, our cosine graph maxes out at 1. Our min value, again, similar to the sine graph, we min out at -1. So we're kind of bounded by +1, -1. And one of the big differences is that the starting point for cosine, the value at 0 degrees or 0 radians, is at 1. We start at the highest point for cosine. Whereas our sine graph, if I jump back real quick, that started at 0. So this also repeats every 360 degrees. So the time it takes me to get back to, if I start at 1, and I get all the way back to 1, it's going to take me a full 360 degrees or 2 pi radians. If you think about it, that's the rotation of a circle. It takes 360 degrees or 2 pi radians to get around. And we're also going to cross every 180 degrees here on the cosine graph, but it's shifted a little bit from our sine graph, right? Our first crossing is at 90 degrees, and then we cross again at 270. If I go backwards, I cross at -90 degrees and then cross again at -270. So our final notes work today is just taking some time to identify what some of the similarities and differences are between the sine and cosine graph. And I'd encourage you to have this section of your notes kind of be your own, all right? How are you going to recognize the differences between the two if you have to select between them? So take a few minutes, wrap up your notes, identify some similarities and some differences between our sine and cosine graph.